So we are now here. I think in the morning today, we will spend a significant part of our time doing the homework and explaining the some of the problems here. So basically, ladies and gentlemen, basically now you are fully equipped with the ordinary least square regression model. What we need to do now is to get ourselves familiarized with starting a model, running the regression, interpret the results. Then in the afternoon, we will have to cope with the violations of the assumption. So now, in this morning, we assume that the data meet all of the assumptions that we have made, and we go on with the and focus on the key points of modeling aspects. Now, so I have just opened the participants window, and now I will ask randomly. Yeah, so it will be the opportunity for you to make some good memory about our student time. Okay, when you look back in 20 years, you may say, okay, I had such a wonderful memory that I could recall important parts of the course. Yeah. So I will open the participation list, and I will invite you to express your opinion. Time flies. 20 years ago, at this moment, maybe I was in your seat, and we were talking about the recently happened 9/11 attack. It's already 20 years. So let's see how we can make our student life memorable. Yeah. Of course, it will be memorable when the ones who have not been given the opportunity to answer questions will be asked first. Now, so my question now must be answered directly and with no hesitance. And I will ask someone. Let's say hello Thùy Dương. Võ Thanh Thùy Dương, hello Dương, are you there? Hello Dương, can you hear me? Yeah, I can hear you, but now it's not quite well. Can you say something again so we can check if we can hear you?
Hello.
Okay, hello. Okay, yeah. Oh, good. So Dương, in 30 seconds, please recall the 6 assumptions of the ordinary least square model. Ngọc Thảo is scrambling for the note. Now, Thùy Dương, what is the number 1?
Am I answering now?
Yes. Number 1?
Number 1. The is the linearity.
Linearity. Number 2.
Is the full rank.
Full rank. Number 3.
Is identity of the independent variable.
Okay, the exogeneity, right? Or the error terms are exogenous. Number 4.
And number 4.
Can you say it? Can you say it louder, please? I cannot hear you.
And number 4 is
Oh, it's already 1 minute. Number 4 is homoscedasticity and non-autocorrelation, right? Number 5, there exists a data generating process. And number 6, is
normality.
okay, normality. That's right. Yeah. Okay. Okay. So that's normality. So please remember the 6 assumptions of the ordinary least square. Yeah, you can people can split the assumptions into different groupings, and they may say you can say there are 7 assumptions. So if you split the spherical disturbance assumption, then you would have the first assumption is homoscedasticity, and the second assumption is non-autocorrelation. But the implications of the homoscedasticity and non-autocorrelation assumptions is that you would have variance covariance matrix that could be written in a beautiful form of x prime x to the minus 1 times sigma square, right? Now, so it is very important that we understand the implications of the assumptions. We make the assumption. Once the assumptions are met, are satisfied, our OLS estimates become blue, right? Blue, that is best linear estimator, unbiased estimator. So now, to build on the knowledge so far, this morning we will spend our time on doing the problems, and especially the problem set that I have sent out, right? So let's now do, we start with some simple problems like problem 1 till 7, and then we will come back to the problem set. The theoretical ones, I would not repeat them. Because for the reason is I already sent you the video lectures from the years before, and in that video lecture I presented all of the derivations necessary for our to answer the questions in the problem set. Yeah, so this was done about 6 years ago. No, 4 years ago. So you know, and then all of the derivations and explanations were done by me 4 years younger than now, maybe at the same time of the year. So if you want to see, the video at the time was taped and edited more carefully, especially At the beginning of of my teaching at VGU, I was more ambitious. So in that course, I included a large body of knowledge, and in the evaluation, I got a persistent complaint from the student that the course was too much. Then I have to adjust, and after talking to my colleagues, we came up with the body of knowledge currently available in the course that you are taking. In the past, I also talk about the law of large number and the proof of what do we mean by the Wald test, the LM test, and the likelihood ratio test, and those things. Let's say they are just the extension of what we have done so far. If you, for some reason, you do not remember some of the discussions we have made, you could visit the video series and find out the answers. For example, in the problem set number 2 that I have sent out, questions like, given that epsilon is assumed to be normally distributed, which means 0 and the variance I times sigma square, explain why B B follows a normally distributed, which means beta and the variance sigma square times x prime x to the minus 1, when the OLS assumption are satisfied. Or define S as the sample estimate of sigma, show that the unbiased estimator of sigma square is S equal to this one. And all of these things are included in the videos. And the problem of including all of the videos for you is I provide you with a sense of comfortability and assurance. Whenever I forgot, I could look at the video and remind myself of the body of knowledge. And you wait until tomorrow is the examination. You start looking back at the videos, and all of them seem to be overwhelming. You cannot even understand any single word of my lecture, and you would, I had a feeling that I was speaking French. At that time, it doesn't have anymore. So recently, we had a problem with other lecturers in the program. They do not allow to record the lectures anymore. And in some universities in Germany, recording the lecture are not allowed. Totally. Completely. Meaning that the lecturers were aware of the fact that the students just simply think I have the video, so I don't need to attend. Yeah. So what I'm saying is, so please don't think that I have the video, so I don't have to pay attention. Okay, good. So now any of the questions, the theoretical questions, included even in the first question here. In the first question here, they are already answered by the video, right? So I can't repeat myself. So with the videos, I can repeat myself a million times. So if you want me to repeat, you just replay the video. Yeah. Okay. So today we might be more. We will be focusing on the empirical work, so that you really have a sense. If you have to run a empirical analysis, or let's say very close to your goal now is to write your thesis, and you want to develop the hypothesis and your analysis of what is true and what is not, then what should we do? Yeah. No, most of the time when you start your thesis or so, you will write to some data provider to ask for a data set, and they would give you something like this one. You would get a huge data set with a lot of files, how to combine them together, how to match them together empirically. So let's say the theories are now more or less done, and we want to operationalize the things that we have done to convert the knowledge that we have discussed so far into the tools, analytical tools that you can use for your now let's now saying maybe the research, the seminar, or maybe later the thesis. Okay, so let us start with the very simple question in problem 1. Now, consider this one. This is the regression we already talked about. Now, can you all please open Stata? Please, now we have to do it together. Open Stata. And then you are requested to load the data on CEO salary into your memory. Yes, so I have done it. I request you to do the same thing. Now, one of the best practice that I want to recommend you is that you open the do file and then you copy the commands that are that you think that are necessary, and you will save it. So I will save. This is to session 2. I can write it maybe the third do file of my life. Yeah, so today we will do a lot with the empirical thing. So we do practice, let's say. Yeah. Firstly, let's start with question number 1. Consider an equation to explain salaries of CEOs in terms of annual firm sales, return on equity, ROE in percentage form, and return on the firm's stock, ROS, in percentage form. Okay. In terms of the model parameters, state the null hypothesis that after controlling for sales, ROE and ROS has no effect on CEO salary. State the alternative that better stock market performance increases the CEO's salary. Okay. Now, so do you really understand the question now? So the first thing you need to do with this question, is to state the null hypothesis that after controlling for sales and return on equity, the return on stock has no impact on CEO salary. So what is the null hypothesis here? H0. Now, so this one is basically talking about hypothesis testing, right? Testing. Now, so what is the null hypothesis here? H0. Now, what is H0 here? I would like to ask someone. Now, Võ Thanh Thùy Dương, Thank you for your answer. I did not hear you very clearly, but anyway, I give you a plus for your contribution. I would expect to hear you in a much a fluent way, talking about the assumptions, like we are singing our favorite song. But anyway, I still got you most of the time, so I give you a plus. Hello, Nguyễn Trần Hòa Minh. Hello, Hòa Minh. So, what is the null hypothesis here, Minh?
The hypothesis is
Now you look at the equation, please. Look at the equation, please. Now, could you state the null hypothesis? The null hypothesis is what we think that what we expect to be true, and then we will use the data to test it, right? So, Hòa Minh, what is the null hypothesis here? Come on, where were you in the last few lectures?
yes.
Okay, can you say it? Can you state the
Yes,
null hypothesis? Okay.
Beta 2 equals 0.
Beta 2 or beta 3?
Oh no.
So the null hypothesis is that ROS, that is return on stock, has no impact on CEO salary.
Yes. Beta 3 equals 0. So I thought that all of them are
Okay. Yeah, so beta 3 is 0.
Beta 3 equals 0.
What is the null hypothesis, the alternative hypothesis here?
The alternative is beta 3 is beta 3.
I can't hear you. I can't hear you. What is the alternative hypothesis?
The alternative is
Better stock
beta 3
market. Okay.
is different.
Beta 3 is
different from different than 0.
Different from 0.
Yes.
Is that true? State the alternative that better stock market performance increases. Now, I take the opportunity of the problem set to mention an extended part of the hypothesis testing. Now, so it is not this one. If they say that the alternative, that better stock market performance increases, that means that beta 3 must be positive or negative, Hòa Minh?
Must be positive.
Positive. So
Absolutely.
the alternative is not that. It is different from 0. It's not. But it must be.
It's larger than 0.
That's it. That is the true, the correct hypothesis. Yeah? Correct hypothesis. Now, ladies and gentlemen, now I want to discuss a little bit. I want to extend our discussion a little bit to the realm of two-sided and one-sided test, right? Two-sided versus one-sided test. Now let me repeat myself, but this will explain will make explicit our hypothesis testing so far. So let's say our test, let's say we talk about two-sided test. So the two-sided test in this case is we are assuming beta 3 is 0, no impact. No impact. No impact. I will have to move it a little bit. No impact. Okay, this is the null hypothesis. No impact. This is H0. And then we talk about H1. We say beta 3 is different from 0. The idea is some impact has impact. Has impact. It has impact, but we do not know the direction of the impact. Has impact, but we do not know the direction of such impact. We do not know. So let's say a favorite example for me might be whether having a VGU degree will earn you higher wages and salary. Now, please follow me. This is the so-called two-sided test. You estimate beta. You know that beta B3 is normally distributed. Now, we need to focus here. You know that B3 is normally distributed with mean beta 3 and variance sigma square, S square, estimated, let's say this is the sigma square SKK. Okay, SKK. And you can write it here. Beautiful. This is one of the best normal distribution curve that I have ever drawn in my life. Okay, so imagine that this is, I mean, the normal. Okay, so what is the value here, Hoa Minh? Hello, Hoa Minh. Yes, what is the value here? What is the center of that distribution?
It's 0.
Is it 0?
Oh, it's sorry, no, it's GK.
What is it? Now I'm talking about the distribution of beta 3. Okay, what is it? Of B3. So what is it now?
It's B3.
B3 or beta 3? What is the mean?
Beta 3.
Beta 3. Okay, beta 3. Now, my question to you. What is the value of B3? What is the value of B3 if we are able to get a sample that is as large as the population?
Value of B3.
Pardon? What is the value of B3? B3 if we are able to get a sample which is as large as the population itself.
It's also beta 3.
That's it. That's it. Okay. That's it. It's beta 3. So if we can get the whole sample, then there is no error. The problem is we have to sample. In reality, it will be difficult to get data on the whole population. And each time we take a sample, it could be either here or here. So most of the time, it will be close to the true value. Sometimes it may fall out too far away. That is because of the sampling error, right? Sampling error. Okay. Now, so this is the first thing we want to talk about. So we do not know the value of beta. Each time we take a sample, we will get a sample estimate of beta only. Now, so then it comes to the question when we want to test. We want to test if beta 2. Okay, so we will standardize B3. Okay, how do we standardize a normal random number? That is, first you define T3 equal to B3 minus its mean, and its mean here is beta 3. Okay, divided by the square root, the standard error, that is the square root of the variance, that is sigma square SKK. I'm saying, sorry, S33. This one will follow a normal distribution with mean 0 and variance 1. Variance 1. Correct? Now Thảo looks confused, but let's say this is correct, right? This is correct. Or maybe that because of the video. Now, but do we know a sigma square? We do not know sigma square. So what we have to do is to replace this sigma square with S square, which is equal to E prime E over N minus K. When we replace this one, actually we divide the standard normal by a chi-square with N minus K degree of freedom, the square root of a chi-square with N degrees of freedom. So this will lead to T3 will follow a T distribution with N minus K degree of freedom. I'm summarizing myself, so I will not go into detail. You know the story, okay? Now this is the punchline. This is the punchline. So instead of having a normal distribution, I would have a T distribution. It looks like a mushroom. Yes. Okay. This is a T distribution with N minus K degree of freedom. N minus K degree of freedom. Hoa Minh, what is the? Oh, I'm sorry. I was asking what is the value here, but I put 0. Hoa Minh, now it's 0 because we already take the B3 minus by its own mean, right? We standardize, so now it's 0. Now, Hoa Minh, what is the difference between, so how does the T distribution looks like when the number of degrees of freedom increases? Hello, Hoa Minh.
Yes, hello.
So, okay.
It looks like normal distribution.
That's it. That's what I want to hear. Now, basically, if we pay attention to our definition of the T distribution, you may see that the Tn minus Tm is equal to the Zi divided by the square root of y of chi-square m divided by m. Right? Okay. Now, the expectation of the chi-square m is m. Expectation of the chi-square m degree of freedom is m. Okay, is m. So when the number of degrees of freedom goes to infinity, you take the expectation of the chi-square with m degrees of freedom will be equal to m. M divided by m is will be 1. The square root of 1 is 1. That's why in that case the Tm will be the same like will converge to the standard normal. I mean you are correct. Okay? You are correct. Now, ladies and gentlemen, so the story is, the story goes with the note here, the story goes like this way. You have a null, you have the null here, okay? You link the null. You have the null, you link the null to a known distribution, which is a T distribution. Okay, so the steps in hypothesis testing, you write the null and you will try to find to develop a statistics that follows a known distribution. That follows a known distribution. If the null is 2, it will follow a known distribution. So if our hypothesis, the null hypothesis here is true, now here, number 1, then number 2, we would have T3 here. This is number 2. T3 here will follow a T distribution with n minus k degree of freedom. Okay, n minus k degree of freedom. So we will compute our T. So for example, we happen to have our T3 here. We happen to have our T3 here. We will ask the question. We will ask the question. How likely? The question is, now this is key to hypothesis thing. How likely? How likely that T T3 belong to T n minus k. How likely T3 belong to n minus k? So I would say, if I make the decision saying T3 does not belong to Tn minus k, in that case, how likely is it? It will be equal to this part up. It could be the likelihood that will happen is that it will be equal to the probability from the T3 and higher or minus T3 and lower. So these are the, so if you consider T3 to be very extreme, then there are even more extreme realizations. But the question is, how much is the likelihood? How much is likelihood? You will say, okay, this is the maximum likelihood that it could happen. It could be equal to T3 or larger or minus T3 and smaller. This is the maximum likelihood. It will be equal to, let's say I put this one alpha, A and B, the maximum likelihood. The maximum likelihood of T3 smaller of any T, Tn minus k, that is smaller than minus T3, and plus, this is the prop, plus the probability of any Tn minus k that is larger than T3 is equal to alpha. Let's say alpha. And we question what is the value of alpha, and this is known as the, so the p-value actually, p-value. This is the p-value. So the maximum likelihood that if you reject the null hypothesis that T3 belong to the Tn minus k degrees of freedom, this is the maximum likelihood that you will make a mistake. Okay. So when the p-value is smaller than, let's say, when the p-value is smaller than, let's say, 0.05, that is we consider to be small, we will say then T3 does not belong to a Tn minus k family. If it does not, so I say, I do not think that T3 belongs to the Tn minus k, because every value that is as extreme as T3, all the values that is as extreme as T3 or more extreme will accumulate to something like less than 5% of the time. So it is very rare. It is very rare. So I conclude, if this is rare, that is T3 is rare. You can never make a completely 100% sure that T3 does not belong to the Tn minus k degrees of freedom, because the T distribution takes the value from minus infinity to infinity. So we cannot rule out completely. But we know if we rule out, what is the maximum likelihood probability that you make a mistake? And when the maximum likelihood that is the p-value that you make a mistake is low, you say that T is rare. So you come back to the conclusion, that is, I reject the null. This is the idea. So if T3, the realization of T3 in this case is very rare, I reject the null. This is the two-tailed test. Now, ladies and gentlemen, this is a two-sided test. I do not know the direction, the sign of beta 3. So I just say, okay, this is a realization of T3, and I would say, if this time it could be this extreme, next time, and this is over here, next time it could even down here. But if I reject the null, the maximum probability that I make a mistake is my p-value. And the p-value, if the p-value is less than 10%, yeah, we start to feel, okay, it's fine to reject the null, but mildly, we say that it is mildly significantly different from beta 3. And if it is 5%, we say that it is significant. If the p-value is less than 1%, we say that it is strongly significant. It's very significant. Yes, significant at 1% level. Now I want to the new term, that is the one-sided test. Okay. Now I want to the next point, that is one-sided test. One-sided test. Now, what does I said now is beta 3 is larger than 0. Because it makes sense to assume that higher stock returns will lead to higher payment to the CEO. It makes sense for that to happen. Right? So we assume, yeah, beta 3 should be larger than 0. If beta 3 is larger than 0, then beta 3 is larger than 0, then we would assume that the T distribution, okay, this is 0. So we would assume this is 0. We would assume the the T3 to fall into this region and up, because we assume that it is positive. So it can only fall into the right hand side, the 50% here. 50%. Okay, because this is 0 and we are assuming that beta 3 is larger than 0. So it must fall into the positive half of the distribution. And we have a look here and we say, so this is the probability. So for example, if we have T3 here, and we would ask the question, what is the probability that T will fall into this part or larger? We no longer take the symmetric side of T, because we know that beta 3, we assume that beta 3 is positive already. So if the extreme value happens, it can only happen to this section. It cannot happen to this section. This section can only be realized if beta 3 is negative. But we are assuming that it is not negative. So it cannot be on this side. It can only on this side, on the positive side. And in that case, when we have the one-sided test, we only consider this part of probability. We do not take the part down here, because we assume that if it is positive, the T3 cannot be negative. If it cannot be negative, the probability down here will never happen. Okay, so the maximum likelihood that I would make a mistake, the maximum probability that I would make a mistake, if I conclude that T3 does not belong to the Tn minus k degree of distribution, then the probability is only this part. So it is only alpha over 2. Alpha over 2. Yeah, alpha over 2. So let me put it in this simple statement. The p-value of the two-sided test is equal to 2 times the p-value of one-sided test. That's the idea. Okay, the p-value of the two-sided test is equal to 2 times the p-value of the one-sided test. Okay, one-sided test. So in the regression table, now let's run the regression. Now I think up until now this is the idea of one-sided test. Now I thank you, Hoa Ming, for that, and I give Hoa Ming a plus. I think you have shown quite good understanding of what we have done so far. Thank you. Yeah. Now, it will be very pressing if I ask each and every one of you in this way, but come on, I'm trying to help. You don't like me? Bad luck. But I won't be there like that. No. Now, hello, Hà Quốc Thái, are you there? Hello, Mr. Hà Quốc Thái. Okay, so I think Mr. Hà Quốc Thái may not be available, and I put a yellow line here. Yeah. Okay, next. Hello, Hữu Phúc. Hello. I think Hữu Phúc is the first year student, second sophomore, right? So if you register and you do not participate, I would appreciate that, because you should focus on the second year courses. Next, hello, Mr. Nguyễn Tiến Phương Nam. Phương Nam, are you there? Phương Nam just finished the first year, so I think these are the students who register for the WPM, but we already made it very clear in our orientation sessions. Do not do that. The program already designed to give you only enough time to do the B courses and don't do both B courses and P courses at the same time, unless for some reason you are not allowed to do the B courses. For example, you fail O-STAR, and if you fail O-STAR, you should not do research methodology, to be honest. Yeah, okay, good. So I have gone through the whole class, and now the ones who are having minuses will be given the priority. Now, ladies and gentlemen, to understand more about the one-sided or two-sided test, please run the regression. Please run the regression as suggested by the question. Now, run the regression if you can come up with the same results. I think we have done that, right? So now I just show you some tips running data. If you type regress and then you double click on the variables, the variable won't be written to the command window quickly. You don't have to type them. One of the drawbacks of typing the variable names is that if you just make a single mistake, either a capital upper capital letter, or you just type one single letter differently from the variable names, then data will return the information that, yeah, I cannot find the variable. So it's ROE, ROS, right? This is what they ask us to run. And this is the result. This is the result. Now I want to ask someone to, now we do the second round. I have gone the first round. Now we will do the second round. I have never invited Phạm Thị Quỳnh Anh. Hello Quỳnh Anh, are you there? Hello. No? Okay. Now next. Dan Thanh, can you join us or you are missing? I received an email from Dan Thanh. I think that you cannot join us today. That's fine. Yeah. Okay. So Dan Thanh just got her vaccination. Yeah. Okay. How about you, Mr. Huỳnh Minh Trí? Where are you? Văn Nhi is not participating. Cao Chí Công is not participating. Now, Phạm Hà Minh Tâm. Hello Minh Tâm. Are you there? Hello Minh Tâm. Okay, I think I got a message from Minh Tâm. Okay,
I'm here.
Okay, Minh Tâm is here. Good. Hello Minh Tâm. So
my computer keeps freezing.
Okay, good.
I cannot use data now.
Okay, that's fine. Good. So, but have you run the regression, Minh Tâm?
Yes.
Yes. Okay. So if you have not, then I'm sharing with you the results. So now my question to you: what is the meaning of this value, Tâm? Hello Minh Tâm. What is the meaning of that value? We can no longer hear you, Minh Tâm. Maybe that's my problem. Hello, you guys, can you hear Minh Tâm? Yes or no?
Oh, no.
No? Okay. Then I cannot hear either. Hello. Hello, Minh Tâm. Your mic is on, but I cannot hear you. Hello.
Um,
Okay, Minh Tâm. Okay, I can hear you now. Okay.
yes.
So what is the meaning of this number?
This Z value.
The value of which test?
Um,
The t value of the test. Which test?
of no hypothesis.
Okay. Of the test that, which is the null hypothesis? What is the null here? The coefficient of which variable?
Z value of ROS.
ROS is 0. Is
Yeah.
0.45. How can we get that number? So it's equal to, that is, we get that number equal to, we define t scalar t ROS. It is equal to the coefficient. Now we follow, we take tbk, that is bk, that is the b of ROS, right? Minus the tested value, the assumed value, that is beta 3, in this case is 0, divided by the standard error of, right? And this is what we would get. So it is the test that the coefficient of it must be SE, yeah. The test that the coefficient of beta ROS is 0. Okay. Ladies and gentlemen, this is the idea. So this is where you get the number. Is that correct, Minh Tâm? You understand it?
Yes.
Okay, good. Now is the key question. Do you earn U plus, Minh Tâm? Minh Tâm, what is the maximum likelihood or maximum probability that I will make a mistake if we conclude that the coefficient of ROS is different from 0? That is, we reject the null, right, Minh Tâm? Then the probability of making a mistake is how much?
65.6%.
65.6%. Yeah. Okay. Good. Now, so the p-value of the test that beta ROS is 0 is 65.6%. Do we reject the null? Should we reject the null? We should not reject the null. Okay, that's clear. Now my next question, this one is important. What is the p-value if my alternative hypothesis is that now in this case, now so the p-value of the test that beta ROS is 0, against the alternative that beta ROS is different from 0 is 65.6%. Different. We do not know the direction, right? So we ask how likely the extreme is, and we draw the t distribution. We draw a t distribution in this way. And then this is 0. And this is 0.45. And this is minus 0.45. Okay? So is it an extreme value? If we consider it an extreme value and we reject the null, we would make a mistake this amount and this amount of the time. Because it is very likely that it will also happen here and 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 here, right? So that is the probability of making a mistake is very large. We cannot reject the null. Now, what is the p-value? This is the key question that I give to you before I invite someone else. What is the p-value if our test is that what is the p-value if our alternative hypothesis is that beta ROS is larger than 0. Em ơi, cháu lấy rồi em ơi. Okay. Larger than 0. What is the p-value, Minh Tâm? It's larger than 0. No, smaller than 0. No, let's say larger to make it to make some sense. What is larger than 0? When we say that our assumption, now I say it again. When our assumption is that beta 3 is larger than 0, then we say it cannot be smaller than 0. So the thing here cannot happen. So we will not make a mistake down here. It will never be negative. Okay? So if we know that it is positive, we know that this is T3, then everything we will make a mistake if for many, because sometimes it will happen over here. Yeah? We make a mistake. But what is the mistake? The probability that it is here from T3 or larger. So in this case, what is the p-value of the test that we are interested in, Minh Tâm? So the p-value, there was 65.6% of the time we will make a mistake if we test a two-sided test. So what is the p-value for the one-sided test in this case?
0.25.
0 point?
I don't.
What is it? Now, if we know, if we do not know the direction, the sign of the variable, we say, okay, if I reject the null, it could be here or it could be here. So I have to sum the upper probability, the probability that it would be too extreme to the negative sign, and I sum the probability that it is extreme to the positive sign. I take A plus B, and because the t statistic is symmetric, it is equal to 2A. In this case, I can completely, exclude the probability that it will be negative. So I have only to take the probability that it is positive. So this one will be, so the p-value in this case will be lower or higher. So what is the probability that I will make a mistake? if I know that it is positive and it happened to be here. So the probability is only this part. I don't have to take the part down to the negative side. So in that case, it will be A, right? So in this case, how can I get a number, Minh Tâm?
0.175.
2. This is the number, right? So the probability of making a mistake is equal to the p-value here divided by 2. Okay? You get my point, Minh Tâm?
I was divided.
So let's say that is what I mean, right? So when you have a one-sided test, you exclude the probability that you will make a mistake from one side, and you only have to focus on the probability of making a mistake on the side that you are assuming, positive or negative. Okay? Now, please have a look at the question again. Okay, so thank you, Minh Tâm. I will invite you again. But I do not feel confident to give you a plus yet. Okay, let's keep going. Okay, now we move on with question number 3. Test the null hypothesis that ROS has no effect on salary against the alternative that ROS has a positive effect. Carry out a test at 10% significant level. Now this is now, so test the null hypothesis that ROS has no effect on salary against the alternative that ROS has a positive effect. Carry out the test at 10% significant level. What do we mean by carrying out the test at 10% significant level? Meaning that we accept that we could be wrong 10% of the time. Even if we accept that, the probability of we making a mistake is larger, then we cannot reject the null. If we accept that, and the probability of making a mistake is smaller than the level that we accept, the tolerance level, we have to reject the null. So what is our conclusion here? So having said that, looking at the result here, should be our conclusion of the test of the null hypothesis that ROS has no effect on salary? Let me invite Nguyễn Duy Trung Đức. Are you there? I guess no. Okay. Because I don't see you in the list, Trung Đức, so I guess that this is not there. He is not there. Yeah. Now I see Dan Thanh is up, but let's say now it's the turn to ask Mr. Vũ Minh Hiếu. Hello, Minh Hiếu. Hello. So what is our conclusion of the test at 10% level? Let's move on. Mr. Phạm Bảo Toàn would not be here. Okay. Now this is a good question. Miss Lưu Nguyễn Thục Nghi, are you there? Hello, Thục Nghi. Good. Okay. Hello, Thục Nghi. So what is our conclusion of this test, Thục Nghi?
I think the conclusion is we should reject the null the null.
Should we reject the null?
We should not reject.
We should not reject the null. I doubt. Okay. So, Thục Nghi, can you explain why we should not reject the null?
Because the p-value is larger than the tolerance level.
That's a good answer. Very good. So, your first answer gave me the impression that you you did not understand the question, but the second answer is very heartening. Okay, thank you. Let's move on. Now, would you include ROS in a final modeling explaining CEO compensation in terms of firm performance? Next, please. Now, this is modeling, right? So, should we include this variable? Of course not, right? Of course not. Then we should not include this variable into our modeling of to explain the impact of or explain why some CEOs earn higher than the other. The return of the stock market does not make any. The return on the stock price does not have an impact. So meaning this is a signal to the CEOs. If you do something, you focus on an ROE, you focus on the sales, but you should not focus on influencing the return of the stock price. Because if you make the price higher, people do not pay you higher. That's the message to the. And if you are doing your thesis and you are interested in asking the question, should I include this variable into my model? Then the question, the answer is probably no. Yeah, probably no. Next, next we go to problem number 2, and then we have a break. The variable R&D intense is expenditure on research and development, R&D, as a percentage of sales. Sales are measured in millions of dollars. The variable profit margin is profits as per a percentage of sales. Using the data in RD Chem for 32 firms in the chemical industry, the following equation is estimated. Now, my question to you is, interpret the coefficient on log sales. In particular, if sales increases by 10%, what is the estimated percent point change in R&D intensity? Is this an economically large effect? Now, how should we interpret the result? Now, I want to draw your attention to this interpretation before you can do we can proceed. If we have several cases, this will be discussed, formalized in the next session, but because of the question, we will deal with it now. If you have y is a function of, let's say, beta 1 plus beta 2 log x3 plus x2, I'm sorry, x3 beta 3 plus epsilon. x3 beta 3 here are things that we don't care. Yeah, we don't care. So if you take the total differentiation, now this is something important. If you take the total differentiation of both sides with respect to x3, now let's say you take both sides, total differentiation of both sides, and we focus on x3, x2, then it should be dy, the change in y, right? We hold other variables constant, is equal to beta 2 times dx2. This is the change in x2, but remember that it is 1 over x2, right? 1 over x2. Times plus 0, because there is no change in all other variables. So because of the log, x is actually is having a non-linear relationship with y. And if you take the derivative of log x2, it will be equal to dx2 over x2. Yeah, so it will be equal to 100 times b2 times dx2 over x2. Divided by 100. Okay, divided by 100. What do I mean by this? This is to say it is equal to 100 times b2 times the percent change in x2. So if we run the regression, if you run a regression in this case, beta 2 is equal to 0.004, then our interpretation will be if x2 changes by 1%, okay, 1%, then y increases by 100 times 0.004 equal to 0.4 unit. Right? 0.4 unit. So unit. Okay. So in this case, we can interpret the results. Yeah. Okay. So if we interpret the coefficient on log sales, in particular, if sales increases by 10%, what is the estimated percentage point in R&D intensity? Now, question 2 is test the hypothesis that R&D intensity does not change the sales against the alternative that it does increase sales. Okay. The test at 5% and 10% level. So this is something for you to think, and then we will come back after 15 minutes break. Yeah, and please, in that 15 minutes break, if you could, please focus on the answering these questions, and so we can have a more efficient exchange later. Hello, Mr. Minh Đức, it's time. Hello, please come back. Okay. I see the problem now. So I keep talking and forgot to turning on my mic and my video. I'm sorry, but that's fine. Hello, welcome back. Hello. Okay, so welcome back, and I have to correct myself here a little bit. Yep. So now, so if we say, so dy equal to beta 2 times the dx2 over x2. So in this case, you would say dy is equal to 100 times beta 2 over 100 times dx2 over x2 times 100. This is, we are changing the number into percentage term. So beta 2 must be smaller. Yeah? Okay, beta 2 must be smaller. So we say, for example, if we have it equal to beta 2 times 0.01, then it is equal to 100, beta 2 over 100 times 1%. That's the idea. Yeah, that's the idea. So if you have, now ladies and gentlemen, if on the left hand side you have this is the so-called level. This is the level. And on the right hand side you have the log level. Then the interpretation is okay, the interpretation is if x changes by 1%, okay, y changes by beta 2 over 100 unit. Okay, this is what should be the right interpretation. Yeah. So if you have on the one hand side you have the level, on the left hand side you have level, and on the right hand side you have logs, then the conclusion is if x changes by 1%, y changes by beta 2 over 100 unit. Why? Because you change the unit on the right hand side, then you have to also to times 100, and you have to divide it by 100, so it will be the same. So in that way, the dx over x2 100 times 100 is the percentage term, but you times 100 already, and you have to divide the beta 2 by 100. Now, so with this, what is our interpretation here? Interpret the coefficient of log sales. So in this case, we have the RD in tens in unit and the sales in log. So our conclusion would be if x changes by 1%, y changes by beta 2 over 100 unit. So how could I make the interpretation here? Now, based on the regression results, what should we interpret here? Now, I would like to ask, now we are, Lưu Nguyễn Thục Nhi already got 2 pluses. Lê Quang Minh Trung, hello Minh Trung. Are you there?
Hello.
Okay, good.
Yeah.
So what is the interpretation of the log sales here?
If the sales increase by 10%, so the increase in
R&D, right? R&D.
yeah, R&D would increase by big total of
Come on.
100.
What is the number here? 10%. Now quickly.
3.21.
How much?
3.21.
Can you say it again? How much?
3.21.
3.21.
21.
Now, based on my explanation here, if sales increases by 1%, what is the changes in the R&D measure? You must take this.
Zero.
You must take this 0.321 divided by
100.
100, right? So it should be equal to 0.00321. Okay? If sales increases by 1%, then R&D increases by unit. Okay, so if sales increases by 10%,
so I would take that number there and multiply by 10.
that is the one, right? Yeah, and the unit here is nothing more than the percentage term, but it has already been converted to percentage. So we are saying if sales increases by 10%, then the R&D intensity increases by 0.321%. 0.031%. Is that large or small?
Not very large.
I think it's small, right? Sales increases by 10%, then R&D increases quite relatively small. Yeah, 0.0231%. That is not large. Is that okay?
Yeah.
Okay, good. I give you 1 plus only. I should have could have given you 2 pluses if you made the answer clearer. But anyway, thank you. I think you already have quite a number of tries, and now is the time for Tuấn Bảo is also required. Okay, I give the opportunity to someone else. Now let's do question number 2. Test the hypothesis that R&D intensity does not change with sales against the alternative that it does increase with sales. Do the test at 5% or 10. Do the test at 5% and 10% levels. Okay. Now, how can we compute the test now? Does not change. What does it mean? What is the null hypothesis here? Ladies and gentlemen, what is the null here? The null here. Now test the hypothesis that R and D does not change with sales against the alternative that it does increase with sales. What is the
Excuse me, Mr. Han.
yes?
May I try because I don't have the credit yet.
That's fine. That's more than welcome. Thank you. I think that's who's that?
It's me, Như.
Okay, Như. Okay,
Yeah.
I see. I only see the number. Okay, good. That's Quỳnh Như, right? Okay,
Yes.
good. Thank you. So what is the null hypothesis here, Quỳnh Như?
I think beta equals 0.
Okay, so the null is that the beta of sales is 0, right? The null is, let's say,
Yes.
beta log sales is 0. So what is this is H0. We call it H0. What is H1, Như? Now, we have to
I
read it.
think H1.
Now we have to read it before we go on, right? Let's say against the alternative
Yeah.
that it does increase with sales. What is the alternative here?
Beta is larger than 0.
That's correct. Beta log
of log sales.
is larger than 0. Okay? Log sales is larger than 0.
Yes.
So what is your conclusion now? Interesting. Let's test our understanding of this process. So how can we test this hypothesis?
I think we should use T.
The T. What is the T value now? How can I compute the T value? Let's say this is let us for the sake of being efficient, we put this on S beta 2, okay? Just to make it easier. I don't have to write down the log sales thing, okay? So the TB2 will be now.
I think, but I am not sure whether it's right or wrong. So I will take the 0.321 minus 0 over the number 0.216, and I get it 1.486.
Equal to 1?
1.486.
This is what you get, right? That's good. That's the
Yes.
right answer. You all agree, right? Thank you, Quỳnh Như. Now, so we want to say what is the probability of having a T that have this extreme value, right? So we would say the command for that is display. This is in verb detail. I think it's I should recall the my maybe second do file of my life, and yeah, this is what it should be. The T prop. Have I used it? Okay. Now I will introduce the new command that we can call. That is to say T display T prop. What is the T? What is the n here? What is the T n minus k here, Quỳnh Như?
1.486.
No. What is T n minus k? So what is the number of degrees of freedom here?
I think it's 29.
29. That's the right answer. Very good. 29. And then we have 1.486, right?
Yes.
1.486. That's the good answer. 1.486. And what do we get here? It is 14 point something. Okay, so when you do this in Stata, it will give you, let me explain. So this is what, if otherwise you will have to use a statistical table, Quỳnh Như, right? So in this case, I already did it for you, so you don't have. So if we have a t distribution in this way, you have a t distribution in this way, this is 1.486, right? And if you type in Stata t prop, that is the probability of a t with 29 degree of freedom and 1.486, okay? It will give you the probability here. Okay, you get me, Quỳnh Như?
Yes, I get
Okay,
it.
so this is the A here. And if you want to do a two-sided test, you have to also include the probability of which is also A down here, right? If it is one-sided test, you only focus on the hypothesis that it is larger than 0, right? Okay, so what is the p-value what is the p-value in this case, Quỳnh Như?
You mean at 5%?
Now let's say we talk about the p-value first, right? What is the highest probability of making a mistake if the p-value, if our t is 1.486, and we are assuming that it is larger than 0. So
Can you come back to Stata?
yeah, right. So the probability is here, right? So what is the probability that that the t of 29 degrees of freedom will fall into this spot and higher?
I think it's 1.699.
Now this is 1 point. The number here. Now let me say it again to clarify. T of 29 and 1.486. This is the probability, right? T prop. It is equal to 0.14 something. Let's forget about that something down there. Okay. This is what we have. So the probability 14.48. So I think the number is quite large. Let's put 8 here. So that is to say, if you have a t distribution with 29 degree of freedom, this is the t distribution with 29 degree of freedom. Okay? And this is the value 1.486. Then the area here is 0.148. This one must be gotten either from a statistical book or from a function in Stata. I just call it. Yeah. So the question now is, so this is to say the probability that a t realization will be at least equal to 1.486 or higher will be 14.8%. Is that right? Yeah,
Yes.
okay. So what is the p-value of the test what is the p-value of the test in this case? What is the maximum probability of making a mistake if you reject the null?
I think it should be larger than 1.486.
That is to be it. Now this is yeah, right. So if you reject the null, let's say what we are saying is,
so it's like it must be more than the t value that I calculate. So then we reject the null hypothesis.
now let's wait for me now. Okay, So we compute, if the null is true, we compute the t, and the t is here, right?
Yes.
And if we reject the null, this is the probability that we will make a mistake. This is the p-value. This is a p-value. Okay? This is the p-value. So this is the largest probability that we will make a mistake if we reject the we reject the null. Okay?
Yes.
So this is the p-value. If you reject the null, the probability of making a mistake is 14.8%. So should we reject the null at 5% level? So if we reject,
no.
okay, we do not reject, right? If we reject, the mistake is 14.8%. Is that right? So if
Yes.
our level of tolerance is 10%, then it is still smaller than this number, right? If our tolerance level is 5%, it's also smaller than this number. So the p-value suggests that that the p-value is the maximum probability that we will make a mistake is larger than any tolerance level that we have suggested, either 5% or 10%. So we should not or should reject the null.
We should not reject the
That's
null.
right. Okay, thank you, Quỳnh Như. Very good, very good. Thank you. Now I'm seeing flying messages from you guys. I will address it very soon. Let me first to give the credibility to credit to Quỳnh Như first. Yeah. That's a good answer. Now let me come back to the question. Some of you are typing in, that is not, no, this must be 5%. Let's say, what is really the meaning of this command? What is the probability of this one? So let me see. Now the best way to check what this number means is to say, if you type 1.96. Is that correct, Ngọc Thảo? Okay, now let's see what is the return of the probability here. Now what I'm saying is, I repeat myself again. We are confusing with the function in theta t prob. We do not know if it returns the two-sided p-value or the one-sided p-value. Is that right? Is that right? Okay, so we will do this one and we see what is the return probability. This is a two-sided return. This is a two-sided return. This is a two-sided return. So this is a probability that a t distribution with 29 degree of freedom is either returns the probability that a t distribution with 29 degrees of freedom okay, with 29 degree of freedom falls into the minus infinity 1.96 minus 1.96 and 1.96 infinity. Agree with me? So this is the p-value. It is the p-value of the two-sided test. Correct? So if we want to obtain the p-value of the one-sided test, we take con đem này đưa cho mẹ thì con muốn làm việc. Chạy đưa cho mẹ ngay, không có người ta đợi. Okay, so if we take, các thi ơi nhanh lên đi vì là người ta đang có công việc đấy các thi ơi. Okay, so if we want to obtain the p-value of the one-sided test, we take one over, let's say this one, divided by 2. Okay, you get my point? Hello Quỳnh Như, you get this point? So this is my mistake. I used the function and I stated that it is a one-sided test, but actually it is a p-value of the two-sided test. So if you want to obtain the p-value of the one-sided test, you have to divide the result by 2. Do you all agree? Yes? Okay. So between Ngọc Thảo and Minh Giang, who got it first? Now let me check between Ngọc Thảo and Minh Giang, who made the message warning me first. It shouldn't be. Okay, Ngọc Thảo is saying it should that this one. Okay, so Minh Giang and Ngọc Thảo, the question now is solved, right? Ngọc Thảo, you okay with it? Okay, good. So Minh Giang was the first person to type in, and Ngọc Thảo is the second. So let's say I will give Minh Giang 2 pluses and Ngọc Thảo 1. I do not know. The one who comes first will get the better recognition. Okay, even though maybe you are sitting next to other, right? Next to each other, right? Come on. Then I divided it by 1 to each of you. Now, let's say I will give 1 for each of you because you are sitting next to each other. So who come up with the answer, with the idea first? Okay, so let's say, wow, that's true. That's true. Where is Minh Giang? Ah, it's down here. Okay. So you know, now you get the idea of the one-sided test and the two-sided test, right? Let's move on. Let's move on with the next question. So, come back to the question. So if we take this number divided by 2, if it is, now it is the case, if we take this number divided by 2, it will be equal to 0.74. I'm sorry, 0.74. So this number is larger than, and it is 0.05. So what is our new conclusion? We should reject it at 5% level. I'm sorry, we cannot reject at 5% level, but we can reject the null at 10% level. Right? Okay. Now, so the conclusion is now I have to write down here equal that one. So this one is over 2 is the p-value. The p-value. Yeah, the p-value. So it is equal to 0.074, and it's 10% level. If we reject it now, the mistake will be 7.4%. It is 7.4%. It is smaller. So if or maybe we say at 10%, we cannot reject. At 10%, we can reject the null. But if at 5%, we cannot. You get me? You get my point? So this is when it comes to the decision point. When it comes to the decision point, you have to take the level of significance. So ladies and gentlemen, if you are interested in Hey Kathy, could you please close the door? And you guys keep silent, okay? You have 2 children and sometimes it's just get out of control. You know, and the modern philosophy is that you cannot use force against them. But I think that may be very wrong. Okay. Now, ladies and gentlemen, so we cannot reject the null at 5% level, but we can reject the null at 10% level. So this is our discussion on whether or not we should. What is our conclusion now? If you are doing an empirical research and your interest question is whether increases in sales will lead to increases in R&D, and your answer will be the coefficient of sales is not significant at 5% level. However, it is mildly significant at 10% level. That means that there is some evidence that higher sales will lead to higher research and development investment. Okay? Or, ladies and gentlemen, if you happen to find that now let me just extend the analysis. If you happen, this is not 1 point something, but it's 2.9. I just take an example, and the probability is 0.004. It is smaller than 0.01. You say that we have found strong evidence because it is very strong. It is significantly different from 0 at 1% level. We say that we have found strong evidence that higher sales will lead to more intensive R&D investment. Okay, so this is the idea of interpreting the results. Okay, this is how to interpret the results. Good. So you're all with me, and thank you for Giang and Ngọc Thảo. Yes, Lê Minh Châu, you have a question?
No answers. Do we need to divide alpha by 2 when we comparing with the number 0.074? Because this is a one-sided test.
No, Minh Châu. Firstly, you agree. This is the question that I am trying to interpret, right? I'm trying to interpret. So, firstly, we need to understand the technical meaning behind the command tprop 29 and then 1.468. Minh Châu, we have to understand this is nothing. It has nothing to do with our knowledge. It's just a convention in Stata. What does it return? It returns the alpha. not alpha over 2. They look the same. Okay, you get my, do you agree with me on this point, Minh Châu? Yeah, so in this case, in theta, it gives us this number. So if we are doing two-sided test, fine, we do not have to change. But if we are doing one-sided test, we have to divide this number by 2. You get me?
Okay, I get it.
Good. Thank you.
Yeah, but sorry, but when comparing it with alpha, like the test is at 5% level, so we comparing this number, the alpha over 2 with 5%, but not 2.5%,
Yes,
right?
yes. No. No, I'm trying to answer in the English way. So if you say we does not divided alpha by 2, right? So I would say no. That is, I agree with you. We do not divide. Yeah. So our tolerance level is 5%. But in this case, we do not care. We do not care about the probability of it falling here. It cannot happen. So we know that if we are wrong, it could be only wrong from here and up. You get me? And then we compare. Okay, if it is 5%, if our tolerance level is 5%, and if it is larger than 5%, we cannot reject the null. If our tolerance level is 10%, and it is smaller than 10%, we cannot reject the null. Yeah, get it?
Okay, I get it. Okay, thank
My
you.
pleasure.
Thank you so much.
Okay, my pleasure. Next, we have problem number 3.
I have a question.
Yeah, Hoàng Tuấn.
Yeah, in the interpretation of if x changes by 1%, y changes by beta 2 over 100.
Yeah, unit.
Yeah. So in this case, if this interpretation is true, then if we look at the function, the regression equation, then 0.321, isn't it beta 2 over 100?
It's not yet. You have to divide it by that one by 100, and it is relatively small.
So this is not yet become beta 2 over 100, but just beta 2.
Just beta 2. You have to divide it by 100. Yeah?
Thank you very much.
Okay. Now we go on with question number 3. Interpret the coefficient on profit margin. Is it economically large? So this one is simple, right? So if you have y equal to, if y equal to beta 1 plus beta 2 times x plus x3 beta 3 plus epsilon. We don't care about this thing. So dy is equal to beta 2 times dx2, right? So if x increases by 1 unit, y changes, or y increases, that's fine, by beta 2 times beta 2 units. Of course, beta 2 could be negative, then the increase is actually a decrease. Yeah, a decrease. That's shouldn't be a big problem. So in this case, they are all in level. So the interpretation should be. I need an expert here. I think the question by Hoàng Tuấn is valid. Yeah, it's valid. It's a good question. And I think the question by Minh Châu also makes sense. Yeah, also makes sense. Because that should clarify your interpretation in the future. So Haha, Minh Châu, what did you do last time? You got a lot of pluses. Now I have to watch the video to see what made me so happy. Come on. But anyway, thank you for your contributions. That would be very, very appreciated. Okay, very, very appreciated. And the questions from Tuấn and Minh Châu just show me that you really follow the lecture and you understand the contents. That's thank you. A lot of encouragement. Now, does profit margin have a statistically significant effect on R&D intensity? What do you think? Now I want to invite hello Minh Chung, you have been very quiet in the last few days. Who is speaking? Who is speaking? I just heard a voice.
It's me. May I
Okay,
answer?
okay, you go on.
Yeah, based on the equation, I think that a unit change in profit margin will lead to 0.05 unit change in R&D.
Yeah.
So I think that if we increase 1% in profit margin, so it also leads to only 0.05% increase in R&D.
Okay. And
so I think this is not economically large.
Good. Okay, it's not economically large. Yeah, it's quite small, right? Now, then the next question for you is that does profit margin have a statistically significant effect on R&D intensity? Do you think it has?
No, I don't think so.
Because the standard error is as large as the coefficient itself, right? You see it here? Yeah.
Yeah.
So when it is
Yes.
when the standard error is very large, you know immediately that if that is the case, then you would have the BK divided by the SEBK, right? And you take 0.5 divided by something of 0.46, it will be around 1, correct? And when the t value will be around 1, so the significant level will be the p value will be very high. Is that right? Do you agree with me, Như? Okay,
Yes.
good. Okay, good. Thank you. Thank you. Thank you for the contribution. Let us now. I will remember this contribution, and I will come back to you later. Okay, because you have just received 3 pluses. Okay, now let's move on. Yeah. So now it's let's say we move on. I need you to really understand and to make the sensible interpretation. Okay, sensible interpretation. Now, the following model can be used to study whether campaign expenditure affect election outcomes. Vote A is equal to beta 0 plus beta 1 times the log of the expenditure by candidate A plus beta 2 times the log of the expenditure by candidate B plus 3 is the beta 3 times the party strength of A. Okay, so party strength of A is how popular the party that candidate A belongs to is. For example, after 2009, the Republican Party in the United States was at a low point. So the Democratic Party was very strong, and Barack Obama, gained a lot of advantage against John McCain in that one. In 2020, again, the Republican Party was at a very low point because of the erratic behavior by Donald Trump. right? So at that time, even Biden is very actually we write it in Vietnamese in a very funny way, Joe Biden. That is, but he still won. He still won the election because no, because of the low point in the Republican Party. Okay, now, so what is the interpretation of beta 1? What is the interpretation of beta 1? Now we come back to the same discussion here. So you have the log and then you have the level, right? So let's go back to this one. Let's go back to this one. Okay, now what is the interpretation of beta 1? This simple. I think now it's just a simple check of attendance and give credit to the ones who are not actually hello Nguyễn Hoàng Vi, hello Vi, are you there? I saw you on the list, so I think you are there, right? Hello Vi. Hello. Where are you? No? Okay, then I will invite Miss Nguyễn Hoàng Vi. Okay, Hoàng Vi is saying that yeah. So Hoàng Vi, can you open your mic? Okay, I can't hear you, Hoàng Vi. We can hear her, okay. So what's the problem with my phone? My. Hello, Vi, can you say something? Okay, I can hear you now. Hello. This is annoying.